In this section, we're going to cover what's called a point-slope form. Now, sometimes it's easier to rewrite the equation of a line in point-slope form in lieu of slope-intercept form, which we've been looking at. So let's say we're going to write an equation using the given slope and a y-intercept. So let's say we're given the slope of the line. The slope is 2, and we're also given the y-intercept. We're given the y-intercept as being minus 3. Okay, so we're given the slope and the y-intercept, and we saw using slope-intercept form that we can just plug these in and be done with it. Sometimes it's easier to write it in point-slope form, which we'll actually go over that in later sections. But right now we want to just get the actual mechanics of it down. So point-slope form is something like this. We have y minus y naught. This isn't y0, it's simply y naught, which quite loosely means the first term. And this equals m times x minus x naught, so the first x term. And this is the general form. This is point-slope form. And notice it's not solved for y. So that's actually really important. But we want to find the general form. This is the general form. We want to find the specific form of the line that passes through the y-intercept of minus 3 with a slope of 2. Okay, so how do we do that? Well, first we can start by plugging in what we know. We know m is the slope. So we know the slope, so let's go ahead and add that in. We have y minus y naught equals 2 times x minus x naught. Okay, now don't get excited when you see all the variables here. Our equations, it's actually going to be written with y and x just like we did in slope-intercept form. We simply need to find values for y naught and x naught. We actually have an easy one because we're given the y-intercept, which is the point, the y-intercept is the point 0, b. And we know that minus 3 is the b part, where the line crosses the y-axis and the x value is 0. So let's plug in x naught equals 0 and y naught equals minus 3. We know these two values because we have the y-intercept and we have our knowledge of what the y-intercept is. So we can rewrite this as y minus y naught, which is a minus 3, always being careful with our negative signs, times x minus x naught, which is 0. And we can simplify this, kill these two negative signs, so we have y plus 3 equals, if we distribute this 2 into the parentheses, which we know how to do, it's 2x, and then minus 2 times 0 is 0, so we can just leave that part out. This is the point-slope form for the line with the slope of 2 and a y-intercept of minus 3. Now, like I said, we'll go over in later sections why this actually might be more useful than having it in slope-intercept form, but for now we just want to get the mechanics down of how to actually write equations in point-slope form. So let's look at a few more. Let's say we have a slope. We have a line with a slope of minus 5/4, and we know the y-intercept is, let's say 6, positive 6. Okay, we want to take the general form of the point-slope form and apply it to the equation of this line. Okay, so let's start out by writing the form y minus y naught equals, let's plug in our slope, so we have minus 5/4 times x minus x naught. All right, now we know these two terms here. We know y naught and x naught, okay, because we know the y-intercept is the point 0, 6. So let's plug these into our formula. We have y minus y naught is 6 equals, our slope is minus 5/4 times x minus x naught, which is just 0. Okay, and you get the idea that whenever we're given the y-intercept, we actually have an easy point because we only have to distribute this slope once because this is just a 0 term. So our equation is y minus 6 equals a minus 5/4 x. And that's our answer. Okay, so we're being given the slope and the y-intercept of a line, and we're writing the linear equation in point-slope form. So let's do a few more. Let's see. We have a slope of 8, and we have the y-intercept, a y-intercept of minus 0.8. Okay, so let's start with what we know. We have a general form of y minus y naught equals the slope, which is x, times x minus x naught. Okay, now we know a point here. We have our y-intercept, and this is our b value, so we have 0 and minus 0.8. Okay, so we can plug these into our equation. We have y minus y naught, which is a minus 0.8, equals 8 times x minus x naught, which is 0. And we can just simplify this. Cancel our negative signs, gives us a y plus 0.8 equals 8x. Okay, we don't even need to write the 8 times 0 because that's just a 0 term, and that's our answer. All right, fairly straightforward. Let's go ahead and do one more before moving on. Let's say we have the equation of a line that has a slope of, let's say 1/2, and the y-intercept is 7/8. Now when we say y-intercept, this is actually the b value of the y-intercept. So we know the x value of the y-intercept is always 0, and the b value is the y value, which is 7/8. Okay, so let's do this in one step. We have y minus y naught, which is 7/8, equals the slope, which is 1/2, times x minus the x value, which is 0. Okay, we still have y minus 7/8 on one side and 1/2 x on the other. And that's our answer in point-slope form. Now again, notice the equation isn't solved for y when it's given in point-slope form. We actually have a y on one side and x on the other, and everything just looks like it's mixed together. This is called point-slope form, and we're writing our linear equations in this form using the given slope and a y-intercept. Now in the next section, we're going to write equations in point-slope form when we're given slope and a point, and we're going to find that is actually the easiest way when we're given those two pieces of information. So we'll see you in the next video.